Hello and welcome to another episode of Modular in a Week. We are on day 12 making effects, and we've done a super simple lo-fi spring effect, a bit more hi-fi or advanced DSP effect, and in the last episode we did the schematic to take control of the effects a bit more. In this episode we're gonna end up somewhere in between those two modules with the PT2399 chip. It's a dip IC like this, and made in the 80s somewhere, and it has been used in countless amounts of effects pedals and effects boards, modules, synthesizers, all that stuff, because it's so simple to work with. So we're gonna go through the datasheet a bit and gonna build the most simple of circuits that you can build with this from the datasheet. And then we're gonna do some experimentation with that in the end as well, I hope. Before we go and do that, I'd like to say thank you to my Patreons, who with their support make it possible to do all the things I do on this channel. You are amazing. Thank you so much for supporting me. And for that there is some more fun stuff over on Patreon that they can watch that everyone else can't, of course. But with that, let's go and see what we can build with this circuit. Now, if you do a search online for PT2399 schematics and go to images, you will get so many different choices here. Schmidt Spitz got one, Music from Outer Space got one, Well Wizard's Small Time, Deep Blue Delay, those two are quite popular, I think. We got Dimension P, a chorus. Hopefully we will look at that. Equinox, yeah, we can go on forever here. But what we got is these two right here are actually from the datasheet. And so if we look at the datasheet, yeah, it's a digital chip with a ADC, analog to digital converter that converts it into ones and zeros and then stores it in a memory and then processes it, and then a DAC, digital to analog converter, and through a low pass and out. And I haven't analyzed this much at all, but there's two inputs, LPF1 input and LPF2 input, and then there's two outputs as well. And I believe it is the LPF1 that goes into the digital circuitry and the delay. We have the application circuit, so here we have the echo, and then we have the surround delay. And spoiler alert, I'm recording this after I actually did I've done the soldering. And I'm doing the echo in this episode where we have the input going in and also going directly out. And this is because we want the echo effect, and then it also goes into the second input there. So this is both a feedback loop and also a direct feed loop to the output. So we get the original signal on the output along with echoes that is feedback through this pot here, if I understand this correctly. I could be wrong. This, you will see in the sound examples that this does create some problems for me because I get too much of the original signal. I would have liked to have less of that. And well, now sitting and looking at this, I realized that the surround/delay would have been a better circuit for that. I got thrown off by the surround part of this. That is because when they say surround, they just mean that this is just for delaying the signal a certain amount of time for moving a speaker in the room. So what you got here is no input straight to the output, so only input and then only output on the output. So there's no feedback and there's no mix of the signal. So this would be a totally wet signal going through here. So I might do this in the next episode just to check this one out as well. But in this episode we are going to make this one. So let's sit down and solder this. Alright, so I have the echo schematics from the datasheet of the PT2399, and I'm thinking of building. I'll see if I can fit 2 of these onto one proto board, something like that. But I'm gonna start with one, and I've assembled all the caps for this. So we're gonna add this. It's only caps on this side, so I'm gonna start with that. Actually gonna start by adding 5 volts. So I want to show a trick if you're using the proto board for doing this, or any other circuit for that matter. You have this first capacitor here, the 0.1 microfarad or 100 nanofarad capacitor. That is on almost all these circuits. There should be one of these between voltage and ground, and so also on this one. What you can do if you're using the proto board is that you can take these, and you need to be steady at hand as well. So these are 0603 SMD capacitors. So here's a small capacitor here. I dropped it. So this on my fingertip there is a capacitor that is the same as this one. And we can directly see that this is very useful if you want to save up space. Working with these on a normal proto board is quite difficult, and it is on this one as well, except if you want to connect it as this between plus voltage and ground, because on the other side you have the we have the ground in the middle, and so we just take D8, connect D8, and we put this one over those 2 solder points there, and we will connect this one to ground. Super simple, except that it's SMD components. So D8, we're just gonna add a dab of solder there, and then we're gonna get a tweezer. And with taking up no space on this board, we can actually, this one we don't need, that one is now connected with a 100 nanofarad to ground. We have one component out of the way, and we can continue with the next one. So just a tip if you're using the proto board. Alright, I ended up doing one of my crazy compact builds. It's all crammed up here in the corner, so there's plenty of room to add another one. But this one is done now. I've checked so I didn't get any magic smoke, and let's go and put this in the modular and see what this does. Alright, so we have this simple just beat going in. I use the IMO because that is a much faster VCA, then the Vectral VCA. None of them is really a VCA, but let's call it the gate. So the IMO is a much faster gate than the Vectral. It has a longer decay, so that's why I'm using this one, to get a really sharp edge so we can really hear the reverb / echo effect of this. So it's just connected a VCO in and out to the mixer, and we start with the, so I'd say the first pot is both mix and repeat in one. So when we turn this up a bit, it's now in a very short delay. And we start turning the delay knob. Maximum repeat or feedback. And here we have the shortest . It's very sensitive here in the beginning. Alright, so that worked really nice. It was really nice sounding reverb, delay, echo effect. A few points. So looking at the schematics, and it says the delay resistor having a value of 10k to 50k may be used. The recommended resistor value is 10k. When the value of the resistor increases, the range of the delay time also increases. And I used a 100k pot here I just wanted to try that out. And when I came up to around 50k, I say it kind of turned around or I don't know if you heard, it didn't do that much the last half turn, but it did some. So I still think the 100k resistor was interesting. I have heard that if this value is too low, the chip won't turn on. So might have that in mind when you either turn it on or use this somehow. I think 2k was around where it didn't turn on. I don't know. Just a note on that. Second note is, when looking at this schematics, you have two different kinds of ground. And looking over here, it says that these small arrows is A, G, and D, and those spirally things are D, G, and D. So that is analog ground and digital ground. And when I did this first, I did the analog ground on the strip, and then the digital ground, I just connected all these together with a really thick wire here, and wanted to see if that was good enough. It wasn't. It didn't work. It didn't turn on when the digital ground wasn't connected to the analog ground. So just in my case, just adding a dab on the ground strip, added that to the ground together, but just so you know that these two needs to be connected together. Preferably though, these two should be as close to each other as possible, with which they are with these with this really thick wire connected to those two. So why did I choose to make this simple one from the datasheet instead of one of the more fun ones from the that is out there on the internet, one of the pedals or something like that? Because of this. So when I bought these, I bought these on eBay, a 5-pack for around $1, I think, so really cheap. But in the same listing as this one, you could also buy this one, which is a PT2399, along with this circuit. So as far as I can see, this circuit is this circuit. And this costs $2.5, $2.8, something like that, less than $3. And I know doing DIY is partly to learn and to do it yourself, but part for me is also a cost part, that it's much, well, within reason, it is much cheaper to do it DIY than to buy some of the more expensive modules. But when you come down to this, or the DSP module for that matter, so this is the DSP module for, that was $12, and then you have this one for $288. I think this is so cheap, so it's barely necessary to do it DIY. I have trouble getting all these parts and the breadboard as well, or proto board is much more expensive than this. You even get a quite nice potentiometer here, which is just $1 most places anyway, and the chip. And so what I want to say is, this is a nice little package you can buy. So I bought 2 of these, which means that I now have 3 of these that I can chain together. Seeing one of these is a block, an echo or delay block, and we can put these together and we can tap them and we can chain them, and that way we can get a multi-tap delay. One thing that is missing on these is the delay pot, and that is just a, I don't know which one, but I think it's that one. So there's just a resistor there. We remove that resistor, and on these 3 legs there we add another potentiometer, and then we should have the exact same circuit as we have here, except for the value of the pots though. So let's do that, and I'll draw a block diagram of what I'm thinking of doing here. So here's a block diagram of what I want to accomplish. An input going into one echo, going into the next one, going into the next one. We can also, with a multiple, add tap outs here, so we get all 3 outs. We can then take those 3 into a mixer and get the output, or we can put them back into the input, either via a mixer or directly into the input. So let's build something like that together. Alright, so I think I have this connected as it should be. So this is part of the fun with a modular synthesizer. I'm on a workbench now, of course, but this is how we should, I mean, if you have just a part of a module that you want to make, you can, with the parts that you already have in your modular, you can build the exact part. So we're gonna add the echomatic here as well, but that is in the modular, so I don't want to add that. That will be the input and output. And here we have the so we go out from the first echo in here, and then we split that channel, So it goes into the second echo and into the mixer. Then it goes from here also into the splitter or multiple, into the third echo, and also into here, and then out from here into the mixer. So we have the 3 echoes here, and we can adjust the volume of these. Then we will take this signal out, and I thought we were going to split this into the output and the mixer, but we're not going to do that. We're going to put this into the Echomatic, and from there we can adjust the signal. So let's see what happens when we do this. Also, we need to add the input signal into this mixer. Do we need to do that? No. Let's go and look at the in the modular, put all this in place and see how we should make this work. Alright, so I finally figured this out. Some error connections with the power and stuff. So they're all 3 on right now. I'm just have power into, or input into the first one, not using the Echomatic for now. So the output goes into the multiple, going into the mixer, and then we add this to the input of the second one. Let's see what this does. So let's take the second output, add that to the third. So the bleed through from the original signal is highest in the first one, of course, because the original signal is not present in the other 2. So that's why this one is mostly of the original signal, and the other ones not so much. So here's another setup. I just have them serially coupled, so signal going into one, just to the next and to the next, no mixer, no taps, no nothing. And here you hear there's a way longer delay. And an idea is then to just take 3 of these, get 3 of these, 3 extra potentiometers, input and output jacks, and you will get a really competent reverb echo effect for just a few bucks. It's just an idea. So with this tangled web, I will end this episode. So we didn't come to a full-out module, I guess, but the PT2399 is a really interesting ship. There's a few, I've given you a few different ways that you can attack this problem at. Just buying these red ones. These ones is a really cheap alternative that is also quick to fix. Building it is of course much more fun, and you can do so much more with it. There's that other schematics, the surround/delay, that I really want to try out, especially in conjunction with the Echomatic. And then also a lot of other circuits. So I will come back to the PT2399 in the next episode as well. But for now, let's leave it at this. Thanks for watching. Hope to see you next time. Take care. Bye.